All right, we are going to be on page 5 in our Unit 8D packets for the snails overtake the aquarium problem. So if you could be flipping there and also have your calculators out. So we've got an aquarium in a teacher's office. It's turned green with algae. And student suggested to put some snails in to clean it up. Teacher started out by putting 10 snails in. 2 weeks later, there's 25 snails. Then 2 weeks later, there's 56 snails, and so on. And you see that start to be represented in the table here. And we want to know when will we be completely filled with snails. So if we look at the table, we're missing some things. So first off, we only have up until 10. Well, if we go down to the bottom, notice they give us an equation. They said a clever pre-calc student came up with this equation for it. So the first column there, that's your T. And then our population, the 10, 25, 56 is what we're getting back. Now, we need to round these to the nearest whole when we are doing them. So we are going to have you pause the video and sub in for, you can either do one of two things. You can sub in 12, 14, 16 individually, or you can put this in a graphs page. When you put in the graphs page, make sure to use your fraction template, and make sure you use X instead of T if you're going to do that. The E is our E to the X that's down to the left of the 1 there. So you could do that either on a graphs page, again, use your fraction template, put the X in place of T, and then do a Control T to get each of the values, or just sub them in individually for that. So go ahead and pause the video now until you've filled in the values at 12, 14, 16, and 18. And again, we're rounding to the nearest whole. All right, so when you subbed in 12, you should have got 191. Subbed in 14, 197. 16, 199. And then 18, 200. So now where are these growth rates coming from? Well, the 7.5 is coming from here. They're doing a slope. A rate is just a slope. So they're doing 25 minus 10 over 2 minus 0. And that's giving us the 7.5. Then the next one, they're taking these two, the 56 and 25. So they're doing 56 minus 25 over 4 minus 2. And then they're doing, oops, I missed one. Hold on. They're using these two to find this. They're doing 103 minus 56 over 6 minus 4. So it's just your y minus y over x minus x, like we've done slopes before, and you get 23.5 for that one. So because it's kind of going in the box above, we won't have anything for the last one. So you shouldn't have anything in this box here. So what your task is now, you've got to take these two and do that slope. Then you've got to take these two and do this slope. Then you're going to take these two and do that slope. Take these two, do this slope. Take these two, do that slope. And to finish off, do those two and do that slope. So you have 1, 2, 3, 4, 5, 6. So you have 6 slopes that you have to do. So pause the video now and do those change in y over change in x's. All right, so the different slopes we should have gotten 22.5 here. We should have gotten 14.5 there. 7, 3, 1, and 0.5. So some things to notice. Notice our rate, which is our slope, it increases for a while, and then it decreases again. So if we go over to the next page, we're going to skip 1 and 2 because we've essentially already filled in the whole table. So in your own words, describe what happens to the average growth rate over the entire 18-week period. Well, that's kind of like what we were just talking about. So if we look here, the growth rate increases until week 4, because we're going 7.5, 15.5, 23.5, and then the rate decreases after that. Remember, that's our slope. So our slope is increasing till week 4, and then it decreases after that. So we would say our rate increases until week 4, then decreases after that. In question 4, in what week did the growth rate first start to decrease? Well, if we increase till week 4, the first one we're decreasing is week 6. How many snails can live in the tank in the long run? Well, when you have, this is what's called a logistical equation, where it starts out being somewhat exponential, then starts to flatten off. So notice this growth rate is getting super, 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 super tiny. It's going to continue to get tiny, and it'll just keep approaching that 200 value. Notice in our equation, 200 is on top. That's what's called the carrying capacity. That is the max value that our function approaches over time. So, in the long run, how many snails could live in the tank? It's 200 snails. Is the snail population larger at 2 weeks, 8 weeks, or 4 weeks, 8 weeks, or 12 weeks? See if you can answer that and how you know. So you should have said 12 weeks and could have said something like based on the table. And in 7, is the snail population growing more rapidly at 4 weeks or 8 weeks? Well, we want to look at the rate for that. So let's look at our rates at both 4 weeks and 8 weeks. Here's at 4. Here's at 8. So 23.5 for 4, 14.5 for 8, so we would be growing more rapidly at 4 weeks. So there's multiple questions in here. But the first one, we would say 4 weeks. And we could say based on the table. At 8 weeks or 12 weeks. Well, if you look back at the table on your paper, at 8 weeks we're at 14.5. At 12 weeks our rate is 3 snails per week. So our rate was greater at 8 weeks in this case. And again, that's based on the table for our rates. So what we're going to do now is on the next page, you have a grid. And you are going to graph for the first 18 weeks. So now we need to get up to 200. So we're going to use this whole grid. Down on the x-axis, we're going to put our weeks. And over here, we're going to do our population. And I want you to, on the y-axis, go by tens all the way up to 200. And then on the x-axis, we're going to go by ones, but keep in mind, we're only going to have points for every other. And we've got to go out to 18 weeks because that's what we have. So what you're going to do to finish this off is you're going to plot your graph. Again, you're just using the points from the table. And we're not plotting the rates, we're plotting the points. So for example, in our table, we have like 0, 10, 225, and so on. So you're going to plot those points and then connect them with a nice smooth curve. And then what I want you to do is take a picture of your graph and upload it on Schoology. So then you'll be done with today's work, and there will be no homework after that. So that's what you need to do to finish this off. So do your graph, take a picture, upload it on Schoology. It doesn't need to be a PDF. I just want to see that you did it. Have a good rest of your day. So finish that assignment and upload it on Schoology.